The other thing is I need to figure out how to get to Tommy. Yes? Did it not start yet? Oh, this needs to be plugged in for that to happen, so if you can just hang on for a minute. And then you can be really mad. It's not going to be like this every day, I promise. I need to find out what time it is. Are you able to log in yet? Maybe, if we refresh it, or no? Tommy. Meeting ID. Okay, so I need to get Tommy, right? Okay, meeting ID. All right, oh, that's on a telephone. Oh, it says it. 86. Okay, 827. 780 and 697. Join. I think maybe. Hey, Tommy. How are you? I'm sorry. We've had a little bit of a bad day, at least for me. They're doing fine, so is everyone. Also, I have to figure out how to do that thing to make it a multiple, so you're able to see my screen directly. Still, did you do that through Hangouts? Okay, so I'll see if I can join the same one on the computer. Let's see. No, that gives us a calendar of days. On telephone. Zoom. Launch meeting. Join. Oh, maybe this is it. Did you say I had to mute something, or did you? Okay. All right. So. All right. I'll be tinkering around with it, like during examples, but are you able to see the board okay if I prop you up just directly in front of it? Okay. If you can't, yell at me. All right? Okay. So, if you're able to go through, sign in. I think we should be able to go by now. I know it takes a minute or two to sort of reboot. The work that we're going to. On a side note, we were just interviewing math teachers like 2 minutes ago, and we had to actually take them into E230 down the hallway because the technology in here is so bad. And it's kind of ironic that we don't want new people like that are applying to go through and see how bad the computers actually work. So we brought the person over there, and the black cloud of death that hovers over me around technology apparently does not just stay in this room. And this poor lady in the middle of teaching something as exciting as completing the square. Who remembers completing the square? So you can remember all the joy that she has in explaining that to 10th grade students. And then, while she's doing it, she goes to start writing on the smartboard, and it's green. It all looks like it's connected. It doesn't work at all. Not even close. But she held her own. Some of you who've had me for a little bit know that maybe in tense situations, I don't know, can be somewhat erratic and emotional and loud and throw things. So the fact that she was able to go through and get it done without that was pretty interesting. Our stuff for today is pretty much hopefully a review. I don't know how much trig they've done with you before. I'm going to tell you this. All the trig that you do is based off of the unit circle and reference triangles. I'll draw out for you what your reference triangles are. But the main stuff that we need to know, now let's see how long this takes before this goes awry. This tells us where the different, see? Yeah. And watch, maybe you'll do a different error. Oh, same one. So that tells you where the different trig functions are positive. Now, and this is going to be even worse, the solution is for me to write on this black pad that you can see nothing on. So pardon me if there's more cursing under the breath as I try to figure out how to write math notes for you. But we'll get there, I promise, and I'm trying. Now, you've got to know this tells you where the different trig functions are positive. There's a graph of sine, there's a graph of cosine. Our angles, our main ones, are going to be, now you can list it out as pi over 6, pi over 4, and I hate doing fractions as side armors like that, so don't do that on your paper. I'm doing this because I can't see what I'm writing. Pi over 6, by the way, is 30 degrees. Pi over 4 is 45. Pi over 3 is 60 degrees. Now, there is a little bit of a shortcut. Let me see. I think I actually saved it. Miss Miller shows this to her kids, and I didn't want you guys to be left out. There's a little bit of a cheater that sometimes, especially in Calc, you're allowed to get away with. So you can list out something like this. Notice it goes SC, big square root on top, 1, 2, 3, 3, 2, 1, and it's all over 2. List that out directly as it looks now, and we'll show you how to interpret it in just a minute. You can always list that shortcut out, because all your trig values come from that. If you know your reference angle, and you have that down, and know the ASTC, you're solid. Remember, the reference angle is the acute angle that the terminal side makes with the x-axis. So as we're doing this out, take a look at 30 degrees. If you're trying to find the sine of 30 degrees or pi over 6, take a look here. Go to the sine row across, and then go to 30 degrees going down. The sine of 30 degrees is the square root of 1 over 2. But you're never going to write the square root of 1 because you passed 5th grade. Who can tell me, please, what you would write instead of writing the square root of 1 over 2? We've got no takers. Thank you. One of us can simplify that down. What's the square root of 1 over 2 the same as? Thank you. This should just be 1/2. You don't write radical 1. That's not a thing. Square root of 1 is 1. So that's 1/2. Now, what about 45 degrees? Well, look, sine of 45, radical 2 over 2. Does that reduce down? No. What about in this case, you'd have radical 3 over 2. Does that reduce down? No. So, there's your fractions. Now do cosine. What's the cosine of pi over 6 going to be according to that cheater? Hands up, please, when you can tell me. What's your cosine going to be? Hands up when you can tell me the the cosine of 45 degrees. Radical 2 over 2, and then cosine of 60 degrees is going to be 1 over 2. That shortcut works. Do we have questions on that? That should make things a little bit easier. Next thing up, by the way, how do we get tangent? There's so many definitions for tangent. No, it's sine over cosine. If you're given coordinates, it's y over x. It's also opposite over adjacent. Oh, another thing maybe that you make sure you know. that SOHCAHTOA is important even at this level, because if you need to know what sine is, it'll tell you. And by the way, if you need to know what the reciprocal of sine is, that will help. It means I'm looking at hypotenuse over opposite, etc. Next one up, we should know what a sine wave looks like. Now, this is something else that comes up. This function right here, sine, is that going to be an even function, an odd function, or neither, and why? Who can recall? Would the sine wave be an even function, an odd function, or neither? Does anybody recall? Wow. That's disheartening. Sine would be an odd function. You know that because it has origin symmetry. And mathematically, we know that f of negative x, plugging in a negative x in the input, gives you the negation of the original function. Do we have questions on that part? Now, cosine. Cosine is going to be an even function, for those of you who are good at elimination. Who can tell me, please, why cosine would be an even function from the graph? How could you tell just from looking at the graph that this is an even function? Yeah. Absolutely perfect. Outstanding. How would we know it's even algebraically? Who recalls how you can test for evenness algebraically, or what happens in an even relationship if you wanted to show it algebraically? Do you recall? No. If I plug in a negative x into that function, what do we get out? The same as the original. If when you plug in a negative x, it equals the original, that's what you would have. Do we have questions on that? Now, let's slide over. Hopefully we can do these, and hopefully we can do them pretty good. This first one up, I want you to make the replacement and show me the replacement and come up with the value for 1. And actually do me this favor. Turn your calculators, set them underneath your seats. I don't want us to be enslaved by a piece of plastic. You're smarter than that. Go in right now, show me the replacement, and then work on evaluating out number 1 here. When you get that one done, give number 2 a try if you can. 1 is the easier of the 2. Now, now when we do this, wait, change anything to stop video. Oh. How do we? Tommy? make this show up so I can just show the screen. Let's see. Oh, we're so close. Hide self view? No. Show the screen. Does anybody know how? Does anybody see how I could make it show the screen? Stupid thing. What's that? Yeah, that's just the audio though. Because this is like the webcam one. Huh. Alright. We'll do our best from the other one. I'll have to figure this out tomorrow. Alright. So, as we're doing this here, maybe we'll drop this down. As we're doing that first example out, you've got to plug in the 1/3. So I would go through, and on your paper you need the whole deal. F of 1/3 is going to be equal to, now we can do this out, but look at how smart we are. We'd list out 1/3 squared times the sine of, now in this case, hopefully you know that would be pi over 3 or 1/3 pi, parentheses around your arguments. What's 1/3 squared going to give us? 1/9. Now, the sine of pi over 3. Hands up, please, when you can tell me what the sine of pi over 3 is going to be. Caleb, what do you got? Radical 3 over 2. Now, when we go across, that means I'd get root 3 over 18. Was that tough? No. Next one up. Now, sine, this one's going to require us to sort of hop around a little bit. But as we're doing this, see how it says right now to start, you've got this cosine of pi radians. Who remembers where I can find pi radians on the unit circle? Who remembers where I could find it? Hands up, please, if you can tell me where I'd find pi radians, or what's pi radians in degrees? Yeah, 180. So the cosine of 180, that means I need to think about my unit circle. So that's over here. What's the coordinate over here on the unit circle? Hands up, please, if you can tell me what ordered pair we'd be at if we were over at this point, 180 degrees or pi radians away. We've got 3, 4 of us. Philip, what do you want to say? -1, 0. And remember, from the unit circle, that's your cosine and that's your sine. The x is the cosine, the y is the sine. Now, the sine of 5 pi over 6, which quad would 5 pi over 6 or 5/6 of pi be in? Which one? Should be in quad 2. And when you sketch it out, if the angle from here to here is 5 pi over 6, what is the inside reference angle going to be? Hands up when we can answer that. Go ahead. Pi over 6. Now, the reason we needed that was because of this question. Let's start off. Hopefully, guys, we can bang out that numerator. Hands up when you can tell me what's the cosine of pi radians going to be. Hands up, please. We've got enough illustration in front of us to show it. What is the cosine of pi radians going to be? We got one person in here. Woo. We are better than that. Take a look up there. Right in front of us. Is this one person? 2, 3. Peter, what do you want to say? Yeah, go to pi radians. Look at the circle. Cosine is -1. How about now for the sine of 5 pi over 6? Now, which quad is that in? 5 pi over 6, which quad is it in? 2. Is sine positive or negative there? So I need a positive value. And really, when I'm taking the sine of 5 pi over 6, that's the same as taking the first quadrant sine of what angle? Pi over 6. Who can tell me what's the sine of 5 pi over 6 going to be, which is the same as the sine of pi over 6? Go back and look at that chart up top. And hands up, please, when you can tell me what we would go through and get. We've got 4 of us, 5. Angel, what do you want to say? Okay. Go back and look. Sine, where was that chart? Way up at the top. And what was it, a sine of 5 pi over 6, right? So I go sine pi over 6 in this case, and it's second quad, so it'll be positive. Okay? So now I need to get an answer for this. There's division there. You can't divide a fraction by a fraction. What else? How could I compute this besides saying, go to the calculator and type it in? What would we do to get an answer to that value? We got 1 of us. This is an Algebra 1 concept. What could I do to get my answer from here? 2 of us. Blue, what do you want to say? There you go. So this is the same as -1 times the reciprocal of 1/2, which is 2. Without the calculator, hopefully you know that that would give you out a 2. Do we got questions on that? Next one up, this is another concept that is challenging for you. If it's telling you to take the cosine squared of an angle, it's telling you not to square the input angle, but to square the cosine output that it's giving you. Let's make our replacement in here. This says we're going to evaluate out the cosine of, and write it out like this, cosine of pi over 3 squared minus sine of pi over 3 squared. Now go up to your chart and evaluate that out. I'm going to wait for 6 people with their hands up that can tell me the value of cosine of pi over 3. We'll wait for 6 of you that can tell me the value of cosine of pi over 3. I've got 1, 2, 3, 4, 5. We're getting there. Jack, what do you want to say? Now, Jack, can you square 1/2 also, or is that too much? Perfect. So now 1/4 minus. Now we've got to take the sine of pi over 3. Hands up for that. We'll wait for 6. Sine of pi over 3. 1, 2, 3, 4, 5. Hey, what'd you get? What do you get if you square radical 3 over 2? Hands up, please, when you can tell me. What we would get if we squared radical 3 over 2. Keep going. Now, I know it's a lot for us, but why are these easy fractions to subtract? Hands up when you can answer that. And hopefully if you did your homework the other night, this would be super obvious. What do I get if I take 1/4 minus 3/4? Congrats if you said -2/4, but I hope we can go all the way down to -1/2. Do we have questions there? All right. Oh. Average rate of change. Now, I have to plead ignorance on this. I'm not sure how much, A, you understand, and B, was taught to you about derivatives, what they represent, why we need limits, etc. But the notion that you started out with of average rate of change as a freshman, actually some of you as a middle schooler, is the same thing that we're doing in calculus. Average rate of change looks at what's happening between 2 known values. Is it increasing? Is it decreasing? It could be a linear function, at which point it's called the slope, or it could be a nonlinear function. You could sort of use it to approximate what's going on and make a model of it. But you've got to know average rate of change. Who remembers your formula for average rate of change? Let's see if I can get this. Oh, wait. Oh, stupid thing. Change. I think I get this to go. Average rate. Oh. So I've done it so many times that I have it literally saved. There's the short one. I'm going to delete this in a minute, but just so you can see it. Function f's rate of change over the interval from a to b, you can find by the function value at b minus the function value at a, or the change in the y's over the change in the x. Do we remember that from freshman year or no? Yes? Okay. I'm not sure how much they showed you about calc, but in all honesty, 2/3 of it comes from an average, looking to get a better approximation to an average rate of change. That's it. Now, let me see if we can get rid of this. Okay. Now, you need to find the average rate of change. All you do is plug those values in. Actually, let's do that out. What time is this? Okay. Really just 9? So, let's list this one out. What would we put in for f of b? I don't need its value, but what expression goes in for f of b? Or do you want to give the denominator? Let's do the denominator first. What's the denominator going to look like? Hands up when you can tell me that. What's our denominator going to go through and look like? Need to, that's your... Those are your values. Questions get tougher. We've got 2 people. We're going to wait for 8 of you. So if you know, we need to know if you know. We've got 3 of us now who can tell us. Take the attempt. That's another thing, by the way. You have to be comfortable making the attempt and getting it wrong. If you want to get ahead in here, I'd strongly advise you, first of all, buy nice erasers, something you're going to want to use. These white ones tend to actually get it off. The other pink ones are a little bit drier and they rip the pages. But understand, you're going to get it wrong. But try. Give me something. What's that denominator minimally going to look like? We've got so far 1, 2, 3, 4, 5, 6 of us, 7. Philip, what do you want to say? There you go. Now, I don't need its value. Just plug in. What would we have is f of b? Well, that would be the cosine of what angle? Hands up, please, if you can tell me what angle I'm taking the cosine of if I plug the b in. Yeah. Hang on. Don't give me degrees, but go back and look at the function again also. Close. Go back and look at the parent function. Plug the b into it. What's that telling you to give? We got 1 of us. Wow. What could we put in that spot? No, because isn't it going to be 2 times the b value, right? Doesn't it say 2 times pi over 2? What's 2 times pi over 2? Fine. Great. Now over here, cosine of 2 times the a value. What's that going to be? 0. How can I get the cosine of pi and the cosine of 0? Hands up when you can tell me how I could figure those values out without a calc. We got 1. Oh, come on. How can I get the value of the cosine of pi without the calculator? Mystery for all time. How would the Pythagoras have done it? Unit circle. Unit circle. Sketch out your unit circle. Now, in this case, we're looking for what? What's the first one? Pi? Right? Cosine of pi, which is here, and the cosine of 0, which is here. This, someone already gave us, is the point -1, 0. This would be the point 1, 0. Which one's the cosine, the x or the y? The x. So what's the cosine of pi going to be? Take a look at your drawings. And what would we say, love? Yeah, looks like it's a -1 minus over. So now I get to here. And again, don't get stuck by the math. This is math that actually they should have been showing you much earlier, but it's fine. What's 1? -1 minus 1. Divided by pi over 2. So now I'm up to this. I can't give that as a final answer. But what can I do? Well, you did it last time. Hands up when you can tell me what you would do from here to work on getting that answer. Great. We got 1, 2, 3, 4. That's 5. We want to say. Perfect. So what's your final going to be when you do that? What did you get as that when you multiply by the reciprocal? across. What do you get in the numerators when you multiply? -4. Denominators? Do we have questions on that? There's two more I think we need to do. I'm going to tell you this, though. It's my hope that you can do out 5 without a calculator. We start freaking out, but it's because you psych yourselves out about it. This class as a whole, understand, is designed to help you become anxious when you see something that looks profoundly complicated, because it's going to get you to shut down. You're going, oh my God, I can't do this. There's one value that would make this problem work out easy. And we're actually going to tell you to plug it in. This causes people to freak out. Look at that. Why is 3 a really, really, really good input to go through and have if you're going to have to evaluate this without a calc? We got one who can tell me? Just some common sense. Look at what's there. It looks awkward, except we're giving you something super easy to plug in. Why? What do you want to say? It causes zeros to happen. Look at your denominator. So R of 3. R of 3 means I'm taking, and again, I'm moving the parentheses outside. This would be the secant of, now watch this. I'm going to do a little bit of mental math right now. I think you can do it too. I'm going to plug a 3 in the argument in the numerator. What is 3 minus 3 instead of x minus 3? So I need to take the secant of 0 and square that. And before, again, I start freaking out, my denominator is going to be 3 times e . 3 times e to what power? Oh. So is this working out the best way possible for us? Yeah. By the way, look at which half do you think is easier to simplify? Let's say it again because we're in calculus class. Which half of that fraction is going to be the one that's easier to evaluate? Thank you. There we go. Now, who's got an idea what the value in that denominator is going to be? Who's got a good idea? In the back, what do you want to say? No. Remember, if it was, keep in mind, if that value was 0, what would the expression be equal to? If the denominator was 0, what would the expression be? It does not exist. However, let's process that down. We want to say, give a try. Why is it 3? So e to the 0 power gives you a 1, and then 3 times that gives you a 3. So we're correct. The denominator is 3. Now I need to do the secant of 0 radians, and then square it. Secant's the reciprocal of which function? Hands up when you can answer that. Secant is the reciprocal of which of our original 3 functions? We've got 3 people. This is hard. Secant is the reciprocal of what? Oh, perfect. Cosine of 0. When you can tell me what's the cosine of 0 going to be? Cosine of 0. We got 1, 2, 3, 4. Back. 1. So what's the reciprocal of 1 going to be? Hands up when you can answer that. What's the reciprocal of 1? 1 is a fraction, is 1 over 1 if you don't remember. Okay, now, you just did that. Are you capable of doing more, or are you tired from that answer? Push yourself. Square 1. 17-ish. Hopefully no one's over 30. But at least 17. Maybe, is everyone here under 20? You're so young and you can do this math without the calculator. Did you ever think in a million years you'd be 18 and in an AP class? They're going, takes 1 and square it, but you can't use the calculator. And people go, so hard. No, it's not. If I gave this to you as a 7th grader and none of this was given, what would you want to do here? Like squared equals hypotenuse squared. You're big boys and girls. Find the missing side right now. Based on the drawing, find the missing side right now. Okay. There's a share screen icon. Let's see. I'm not giving up, Tommy. I'm trying to find you a share screen icon. Where is that? Down here? Oh my God, am I this dumb? Oh, Tommy. Oh, I'm sorry. What a doofus. Oh. Wait, is this it? Would this make it be you only see the board? Oh, it's some other board. Okay. Oh, it made a board. Oh no. Stop share. Okay, but we didn't lose Tommy. Okay. Well, sure. Let's share this. There we go. Can you see this? Okay. I'm gonna hide self view. All right, I'm gonna put you. Don't get mad, Tommy. There you go. Actually, we may see Tommy up here. Okay. All right. Now, what's the third missing side going to have as its value? Hands up, please, when you can count. What do you got? 9. Now, another part of this and another part of Calc is there's going to have to be a little bit of active problem solving. Like as you're going through and doing this, you can't shut down just because it looks different. And a lot of times you're just going to say, well, what can I get? And what am I looking to get? So this question is a good one. I had to go over, I actually was thinking I did something wrong on it. So, doing this, your task is to go through and isolate the d theta dt. So do me a favor, circle the d theta dt. It's as though we're 5, and you're learning how to solve all over again. Our job is to get that d theta dt by itself, right? What's up here that does not currently have a value in it, but that can be assigned a value? Take a look at what's there. What can I assign a value that's up on the board right now based on the given information? I got one person who sees it. What can I get a value for that's up there right now? What do you want to say? I think she's on the right path, but there might have been something missing. Your value that you said might be right. The dictation on it might slightly be off. She said solve for theta. We can't solve for theta, but you can solve, because theta is the actual angle number value, like it's 42.7 degrees or whatever. We can't do that without a calc. But What you can do is tell me what the cosine ratio of the angle is. What is the cosine ratio of this angle? Like you were saying, you would look at what two sides? Oh, careful. We only need, you could do both, but which one do we need? We just need the cosine value of that angle. Can you take the cosine of that angle? You absolutely can. Hands up when you can tell me what's the cosine of that angle going to be. 2 people, 3 of us, look at the picture. Jack, what do I say? Cosine looks at adjacent over hypotenuse. So this would be, and what did we say it was? 9 over 15 is equal, times d theta dt is equal to negative 2 over 15. Now, how would we go about getting our answer now? How would you get d theta dt alone? Now, most likely you've done something similar to this a striking number of times. Please multiply both sides by the reciprocal, which means left side and right side are going to get multiplied by 15 over 9. Just as a refresher, if you are multiplying fractions, you can reduce immediately, or you can just go through and multiply across and then reduce. But what's 15 nines times 9 15s going to give me? 1. What reduces out here? You got 15 numerator denominator match. So what's d theta dt going to be equal to? Negative 2 over 9, is that right? Can you do that? Is it upward? Yeah. Understand. And this is just to be honest with you. Stop thinking you're going to get it the first time. I'll tell you this. This is my 7th time teaching it. I still learn new stuff every time I go through and do a different example. This course has been doing it for 40 plus years. She gets more enjoyment out of learning new things about Calc every single year. If you think you're going to leave here with some Calc master, you're wrong. You're absolutely wrong. One thing too that's a little bit interesting. So we had an AP conference a couple of years ago, and I remember when we were there, the guy that taught it was actually like somewhat controversial to bring the guy in because he taught at some very prestigious. If you're a wealthy politician, they tend to live in Washington, and they have kids that go to school. You can't send your kids to, if you're a sort of super wealthy, famous person in Washington, your kids don't go to public school, they go to private school. This guy taught at a private Jesuit high school. He has taught the children of 3 former presidents, and got invited to like multiple, like, he said, I think he had Christmas dinner maybe with the Obamas a couple years ago. They had 2 daughters, I think, that went to his high school that he taught at. But it was a religious school. It was a Jesuit high school. And so it was a little bit awkward. He talked about calculus, and he talked about religion constantly. And he goes, every time you get lost in life, you've got to take a minute, pause, and come back to it. And he goes, I learned that from going through and doing calc. He also goes through and said, every time I think I know something, the more I try to learn about it, and the closer I get to it, the less I actually know. And he goes, and that's a huge calculus concept in and of itself. We'll see graphs that we're going to go through and do this year, and it will look, oh, actually, you know what, it might look as crappy as this. Like you'll say, oh my God, there's this little bit here that looks a little bit weird. And then we'll stop and say, well, what happens if I zoom in here? And you'll zoom in, and you'll realize that this function that looks linear except for this one little microscopic blip on your calculator, you can zoom in and see graphs inside it that you didn't know were possible. Of oscillating functions, non-linear functions, greatest integer functions that show up only when you zoom in. You don't see it unless you take yourself out, take a step back. And he kept saying the same thing, even about your life. And he always said, he'd say, oh, you know, they would relate it somehow to like a religious experience finding these little things. Now, it doesn't need to be religious in a formal sense, but it should teach you something about yourself. And that's what he said. He ended it. Because the whole time I'm at this Jesuit school, he goes, to be honest, I think I'm becoming an atheist. He goes, but everything that I learn about Calc leads me to believe I just need to stop and appreciate what's around me. Same thing's going to happen here. You're going to learn so much about yourself. I can guarantee you by the end of the first quarter, we'll have a real good idea of how you're going to be doing in college next year. A real good idea, and it has nothing to do with your calculator. I had kids who bombed first quarter, who are off at, well, most recent one I talked to is off at Fisher in the pharmacy program there. She went through class, maybe passed one quarter legitimately on her own. Sat through the whole thing, goes back and goes, oh my God, I'm helping other kids in Calc now, I'm working with the math lab over at Fisher. I get it now. It took a minute or two to go back and see it, but now I get it. But she never gave up on herself. Never. And it's the same thing for you. You're not going to get all these questions right. Not even close. But if you sit there and go, I'm not going to do it, guess what? There's 15 other people who will pass you by that day. And Calc's cumulative. Don't fall behind. Stay with it. And I'm going to give you something a little bit different for homework. We're going to see how good we are. Slide back over, please. I'm going to send out a couple of things, but one of them for us has to deal with limits. And that's going to be, and it's only limits graphically, don't worry about that. I want to say it's actually 23 through 27. Just quick limit questions. Did you do stuff like that last year, yes or no? Now, is there a bunch of them there? Yeah. If this takes you longer than 30 minutes, you're doing something wrong. It's not supposed to be that long. It's supposed to be, I want to say easy, but easy. You get stuck, ask Mr. English. You can come and see myself. I know there's a bunch of them there. I'd rather give you a bunch easy to do than give you no homework and you come in and just, bluff it off. Get solid on it. We need you to know limits because limits help us prove things aren't continuous. By the way, did you go into continuity in pre-calc or no? Raise your hand if you heard of continuity before. Okay. Continuity happens, but we need to know limits in order to get to continuity. And if you can do continuity, you can do a derivative. Did we do derivatives yet? Some familiarity with it? Who can tell me something they remember about a derivative? Tell me, what do you remember about it? You're giving me cheater shortcuts. What is it in general? If I say the derivative is 10, what's that mean? Does it mean it's got a lot of money? Does it mean it's very good looking? What? I said the derivative is 10. Do we know? What? First derivative is slope. First derivative is your slope. I'm trying to see, I got us some paper so we can make a foldable, like we can make one and try to keep it for the whole year. But the last thing that I'm going to ask for you, I need to get to know you guys. So, do you have your all about me's done? I'll go through, and if you want to hand those up and over, that would be a help as well. I don't judge your drawings of yourself, I know. I'm expecting art, guys, so. Just that worksheet, that 12.1 there at the end, that's it. One thing, by the way, did you guys raise your hand if you signed up for Remind messages? Any more of these all about me? Who signed up for Remind already? So what I'm going to do for you, you're going to get posted in Classroom and Remind are the instructions for signing up for your Math Excel account. I'm going to send it out to, I got to get our code authorized, etc. It's going to come out today. That's going to be part of your work as well. If you can get it done by the weekend, it would be great, but don't wait. For some reason, these codes, they limit the number of them that we have, so once we find one that works, you don't want to wait until they run out, because there's like 40 accounts you can get from these codes. And if 2 classes get one, and the 2 classes have 50 kids, and there's 40 signed up on the account, you don't want to be the ones who don't get in. So you're going to want to make sure we get your Math Excels done sooner rather than later. I think there's like a brief orientation in there as well. But get that done hopefully tonight. Have you raised your hand if you used Math Excel before and stopped? Okay. Okay. So you may already even have an existing account, at which point you'll need to reset your password. One last thing on that, when you go in and sign up, if you sign up for Math Excel, don't use your Webster CSV email as recovery email because they can't send an email because they're not part of Webster. So just use your personal one. All right? So, Tommy? Tommy, are you there? Does this work now? Is this how the other teacher did it so they could see them? Perfect. I'll remember next time if I forget, call me an idiot and remind me, okay? Thank you. Now, no, is he in your account? No. I'm only down is going in his measurements. Or should he kind of teach? He's probably doing it just online. Like not using the site. Thank you for asking. Tommy, is that right? You don't go to Mr. Waltman now? Okay. I'll bring you down right now to Miss Met, but if Waltman needs you, then Waltman needs you. I'll go down and check with Gorilla and see if Waltman is expecting you like this.
He called for attendance.
Oh, he did?
I don't know.
I'll go figure it out though, Tommy, all right? All right, thanks, bud. Bye-bye. Okay. I believe the last going on down that's the way for the government, right? Yeah. Sorry,
We don't have any comments. I mean, we'll take it. You come in 6.
Okay. Mr. Mack is not here right now. He might be dropping virtual. But this is his smartphone.
Okay.
And currently, it looks like he has it. Yes, he has it plugged in, so he's not on the wireless.
Okay.
And,
You have a wireless transmitter?
well, the Bluetooth.
Oh,
Yeah.
yeah, no, I forgot about those things.
There it is. Let's see.
Is it always in that same place?
No. It moves. See, you're on it. And then, Tommy, are you watching? Tommy's here. They're zooming. So they, like, but then you can go back over.
Slowly.
And it's not doing my favorite one right now, which is when you touch it.
So it's not, it's finger, it's everything.
Yeah. And then if you, my favorite one is if you touch it like this, sometimes it shoots a line straight up. That's a fun one.
And you have you put a different machine on it, it does the same thing.
I've only switched out the pen. I have not taken like the physical board off.
Different computer though?
Yeah,
Different
yeah.
computer, and you saw the same thing?
Yep,
on the
Welker
computer.
came over with this.
And this is screwed down now or is it not screwed down? Boom!
Yes.
One screw there. So what happens if we take that?
I told you what high tech only is.
That's right.
They're really light.
They don't, it just keeps them from bouncing. And the good news is we've got it on, and it looks like a wooden
They
screen.
usually put them on wooden stuff.
And so in theory, it shouldn't be.
Oh, hang on. Oh, no, that's not. Yeah, that's one second.
We should be able to choose a pen here.
Oh, yeah. And I. That was it. I'm gonna be so annoyed because I spent like months doing this.
I hope we can erase it.
Okay. See, his big thing is he starts doing like math equations.
What is that? Go ahead and try it.
Not doing the very fast. No, kind of started, but only enough to stop. So I just need to gas tape the cord down. This just goes like so.
So it's only vertical lines. So it's doing. Oh, did you know you do this?
Yeah. You're tall. You can reach out.
Well, all right, good point.
I'm not for I'm not. I like to joke that I never get spider webs in my face.
All right, so
But it wasn't doing that.
you've run it through the smart calibration, right?
Yeah, he calibrated before every class. Not saying that it was 100% calibrated right now, but
We wonder, so we've moved on from smartboard, and we're using the Cortex boards in our building now. And in the Cortex boards with Miracast wireless devices that transmit both keyboard and mouse input from the Cortex board back to the computer, which means I can do this wirelessly while wirelessly broadcasting the videos. In that process, I found that Windows also has its own calibration tool for when it's in tablet mode.
oh,
I don't know if that, let's calibrate the SmartWise first. Let's run it back through the, you have to remind me how to do that.
It's you just hit these two buttons. So, okay.
And this is 6 points?
9.
Gotcha.
I've done 16 on this too. Does it make a difference? But
Better. Not great, not perfect, but better. So maybe if we go this one, press and hold. Orient. Oh, no.
this one is this one.
Let's get rid of 6.
Yeah, it'll go straight.
I had people tell me they really shouldn't do this with pen.
I had people tell me you have to draw a 6-inch line from it to the center of the dot with the pen. I've heard a lot about this recently.
All right, moment of truth. That's a straight line.
Big one is. Oh. Right now. Do you think it was that screw? And then a calibration screw?
I do. So I think your calibration, as long as this is 5 degrees, will still be a problem until this is stuck down
So
somehow.
how do you recommend I use? Because my thought is giant piece of gap tape and just
I think I'd go double stick,
double stick tape?
if I was gonna do it, or a big piece of Velcro maybe.
Okay.
You know, you could, and most of the time when the AV repair guys were doing it, they were putting plastic washers between that brace and
Yeah.
the board, and that may work. I've never quite, logistically, I never
Why
quite,
would that?
because the screw should connect to the metal behind the board, and then tie the metal in the bracket, and wouldn't it still,
It was sub-ground.
that's what I thought, but that's how they say I always think of it. If it were me, especially if it's a short-term thing, I'd find a good piece of double band sticky tape.
I have
On these,
I have Velcro, those extra duty Velcro strips.
those will work too.
Will those work?
Yeah,
Okay, because I have that in my work.
I'm sorry, is there 4 children here? Maybe I'd put it on the back of the control panel here,
Okay.
because that rests pretty close to the wall, and on this round foot thing back here.
Okay.
So it'll hold it a little bit proud, but not much. And as long as it doesn't bounce, your calibration will be
Yeah.
fine.
Okay.
So, but yeah, the problem with this now is that the way that the bracket and cleat works up here that this hangs on, is the cleat hangs on the wall like this, and
Yeah.
then there's a matching cleat like this. So you bump this thing or you lift it and it pops right off the
Yeah.
wall and falls down.
It's always more fun though. I love how he's got extra pens.
Collect them when you can.
I got a box.
That's how you're going to do it.
Will fall.
Nice! Bosse's was here, they screwed your board up, and now it's gonna fall off the wall. We don't have a bad reputation already.
Hello. I wish you met this man. He's a
Perfect.
I'm gonna go get that. That's right.
Tommy can be the witness.
Tommy thinks us.
Good morning, and please excuse this interruption. Could I have any junior EMCC student, any student who attends EMCC or New Visions for a junior, please come down to the auditorium at this time. Any student who is a junior in EMCC, please come down to the auditorium at this time. Thank you.
4, 5.
She's gone now, she's not walking around.
No. Here, do you want some of these?
Sure.
Want one? I'll pack this on home. Gonna try it? Yeah. You know what we need to try? See how it works now? Oh, it's kind of good. No. So this now works though, and yeah, they were doing it, and apparently it does. Starts coming out now. Yeah.
You'll stop it.
No, I'll still be bitches, but at least we'll be able to go through and do some work now. Tech tip. You got some stage. What?
This calculus thing, look at your paper on your smartboard.
What do you mean?
Tech tip, use the ask table on your.
Oh, that's
like
a
that.
stage.
Yeah, that looks like a stage.
No,
Yeah.
I put her stuff in the end. I put some supplements in the end. This works.
You're the technology shit.
So there's good and bad. It definitely did. And I will say,
The person felt like that was part of it.
Andrew?
Like he was supposed to do that.
I was
Very-
shitting a brick because of it. And they're going to be so nervous coming in.
Yeah.
Like, I cannot imagine the stress of going, oh yeah, by the way, we don't even know if the computer is going to work. Or you thought it was going to work and it's not. And thank God Jackie said, make sure we have a backup document camera. Because we told them in the spiel that they'd have one. I'm like, okay, thank God we did. Everything was green, hooked up. She walked over after, this was another good one. She's like, well, can I have it so I can look out to the kids, like from my computer? Like, can I have like a podium coming out? I go, sure. Well, the screen I couldn't duplicate and make all the screens match. So the only way I could figure out to make it work would be to have this have a display on it of what the computer is, that to have the computer display, but the computer monitor not working.
Yeah.
So we almost had to shut this, but you need the directional pad because the mouse won't connect and the keyboard won't connect. So essentially this was her mouse and keyboard that she needed to type on. So she's like, all right, I need to type on this. So she's going like this. She had to type like this while she used the Elmo to project out to the group. And she had a backup of her paper file, a paper copy of it to do that with. I can't tell you, like I left, I'm shitting a brick. She went up to the board, I think I told you, she touched it and it just turned red. It immediately disabled. So I'm like, I don't know what to do. I tried plugging it in, but I think the whole computer needs to be restarted when it does that. She handled it very easily.
Like a pro.
I couldn't even notice much more of the lesson because I was so fixated on what was going wrong on our end.
Yeah.
And she did not let it impact a single part of the lesson. She was
Now, who was she teaching it to?
She was teaching it to my Enriched 1 group. So LH2 Enriched kids, they had already seen it. I told them, though, beforehand, the kids, understand this is someone's job interview. Your job is not to provide a barrier, but to let them showcase what they know and to let us see what their strengths are. As kids, they're going to ask you soon, would this person be a good teacher for everyone? Keep in mind, you've been in rooms where there's good teachers and where there's bad ones. You know how people like you learn, and you know how all of Schrader learns. Stop thinking about would an enriched person do well, because frankly, I could get fired and replaced with a monkey, and then someone could do it with you kids. Think about your low-level peers. Did they explain well? I thought she did well. Michelle was there, and I didn't get to debrief with anybody afterwards. But I will tell you that I was in absolute awe of her adaptability.
Yeah.
And
She was completely flexible, didn't throw off her lesson. You
I can't
visually notice her like demeanor change or anything, right? Cool.
I'm telling you though, as an adult, it was almost the type of thing where I was thinking it might be worth calling her back to give a lesson just in a functional technology space, because it could not allow you to see how good or bad the instruction actually is. And
So, I heard that you had administrators in there, right?
oh yeah, and I made it a point to point it out to them that it wasn't working. Like on the way back, I looked into his.
But who has a smartboard that's working 100% properly?
I don't know. I think I may. Because what ended up happening was Jenna was walking around with someone from Monroe Bosse's. Jenna brought him in here. They showed him everything. And the person from Bosse's goes, oh, it's this. And it's like a screw underneath. And somehow she Velcroed this thing to the board, to the wall. But I to be honest, she can explain it. I'm ready to give him a kiss. It works now. Like this happens now.
So it's an installation problem. They're all
may
installed. And
check with Jenna, because some people's problems, like I just told Mark, and like mine works now, well then Mark's immediately cuts out like on cue.
What is it? Because like as you're pressing it like alters
It was-
the board, so then there.
It was electrical interference.
Okay.
It was something to do with the screws, like Smart
You have
Notebook
that
said.
hardwired now?
I don't know. I'm not changing anything. Like Andrew,
I know.
I got it. I ain't moving. But
You open documents with your fingers.
I don't know. see? So I can drag in here.
Yeah.
I can switch. This was her thing.
Oh my God, yeah, look at this.
It looks like it's
So
working.
close that for a second. Oh my God.
Maybe it's having it hardwired as a clue. But Andrew,
But
what,
from the desktop, can you double click and get things open?
on extended
No,
display.
there's an infinite canvas. No, so that's still not.
Yeah, I don't care about that. I can do.
Well, to be honest, it might be pulling it up.
Oh, wait, no. You're right. It brought it up on the other monitor. Like it's on this top one now.
Mine doesn't work.
Okay. So this bottom, I just need to know my,
They need to come back and fix it.
just in all honesty, it's Jenna. And if this works, I was not kidding. I will call whoever it is from BOCES and personally thank them. Like this has been 25 hours of my life.
No.
Go
I'm
see.
frustrated because today I was writing, and sometimes it was picking up on my writing, but then as I kept writing, sometimes it would swing things around, and like it's just, there's no rhyme or reason to the board when it works and when it doesn't.
If it's me, and this is what I told Mark and what I've told others, we don't need more boards. The setup that they have and that they're apparently either have or are going to at East Arundecoit is 2 TVs, not smart boards, not Dell boards,
Yeah.
television, so
Yeah.
projection only,
Yeah.
next to each other. One of them would have on it the calculator display, screen display.
Yeah.
The one on the other side is for your notes, but the teacher's input method is just a writable computer with a Bluetooth connection to that individual computer. That's it. And the extended display is the second monitor.
Are they gonna buy us one of these? Are they gonna buy us a brand new laptop?
They would need to get us something that works.
Like a Surface or something
Well,
like that.
Andrew, I'll show you this because I said to the gentleman from from East Arundecoit,
Yeah.
you don't understand. This is the only computer we were told we're allowed to get
Yeah.
because everything needs to be the same.
Yeah.
And he goes, just so you know, this computer, this exact one, they make a corollary to it, which is a Surface writable one.
Yeah.
All of the specs are the same. One of them is like 550A and one's 550B.
Yeah.
He was like, everything else is the same company, the whole deal. He goes, we gave our teachers the option to choose
A or B.
A or B. He goes, everyone from the math department chose A.
Because they want to.
Or because the writable one.
Yeah.
And he goes, and everybody from the other departments in the beginning chose B.
Yeah.
Well, he goes, and over time, they switched. Most of our teachers now have the B version,
Yeah.
the writable version.
Yeah.
But some still have the A, and it's
Yeah.
like, they all work.
Yeah.
They're not different. So here's the text message I sent to, and I save it because I view it as,
Two TVs, two fairly large screen.
No,
TVs
I'll tell you
would
this.
be cheaper than a Dell board, right?
each television is about $500,
Yeah.
our price. The computer itself with our discount is about $1,000, but let's go list. 500 on each of those and 1,500 on there puts you at 2,500 in per math teacher.
Yeah.
Or you could get this computer, which is $1,500 still,
Yeah.
along with a $1,500 Dell board,
Yeah.
which by the way means now you have 2 inputs that can go wrong.
Yeah.
This or the Dell board, where
Yeah.
the other one is just a TV. This is what I sent to Eric
Yeah.
in July.
Yeah.
2-in-1. This is it. Can we get this or just to try? Ready for the most aloof answer you've ever read? Now, I don't even know who's going to be the president next week, much less in
Yeah.
3 years.
Yeah.
We have to wait that long? Are you insane? So 3 classes of kids need to come through with poor instructional mediums. Guys, you want to explain it to their parents? I can't deal with it. And it's, at least during the observation, they got to see what we deal with on a daily basis. No one gets it. This job sucks. And it sucks the energy out of you. We don't need adults helping to suck that energy out.
So when I hit this,
Watch. Click on it. Opens up there.
so now if I want to do a document, I can do everything from here.
I
can
think so.
change it. Look at
Now keep in mind, I'm up. I can go up also. Like on my screen, I'm saying this display, when the mouse is here now, now I bring it up, it's on my second one. So it's not going away, it's only going away on the display, if that's what you're saying. It's opening up stuff too. It opened things up
So
just
you
up
have
here.
it set up so that it's above, because you.
Yes.
So this is mirroring that.
Yes, because I don't know if
And
there's
this is
another.
a different display.
Yes.
But this is your primary display.
This is an
These are your
extension.
secondary displays.
Hang on.
Who set that up for you?
Jenna or someone, yeah. So I even had to write it down. 1 duplicated
Yeah,
to 3,
yeah.
which is the board.
Yeah, and 2
And
above.
2 is above it, and you have to drag them on
No,
top.
I know how to do it.
Oh, okay. I had
Yeah,
no idea.
yeah.
It took a month. So I have
What
that.
I'm jealous of right now is the fact that you're able to actually
Open.
control things from the smartphone. I
Right.
cannot do that.
You can input on you can write on it though, correct?
I can write on it, but it's iffy.
Okay.
So I should ask Jenna if she took notes when that person.
I believe that she did, but thank you.